Good day, sir. My name is Sun Ming Hong, and my matrix number is MH19041. I am from Group 3, and our project car is Honda CR-V. So, abstract. Our SUV must be installed with eco-engine, and our concept model must contain minimum size for single seat, zero emission, and also minimum power consumption. Our project's technical features contain overall length, overall width, overall height, and also wheelbase. And our target buyer is middle income group. So here's our project contribution part. Mm, My contribution is brainstorming a company details, while DUBOYUAN will be responsible for company marketing and sales. Daniel will brainstorming about methodology of design. So SOBAN will be responsible for technical features in more detail, while Sharvindiran will be responsible for product 3D sketch and also doing CFD analysis. So here is our introduction, our project background. The demand of SUV keep increasing these few years, and many manufacturers have started working on SUV. But some of the SUV are not stylish enough, while some has low fuel efficiency. Hence, our company plan to design a SUV that is stylish and also have high fuel efficiency. So for our company, Autopro Sdn Bhd is an automotive manufacturing company that had been operating for more than 30 years. So our company provide cars manufacturing and also designing service. Our company located in DLB Highcom Automotive Park, Pekan Pahan, and sales dealer all around the world. Our company focus is on producing vehicle that has high performance, high fuel efficiency, and also stylish. So our project objective is to design and build an SUV that has high fuel efficiency, and also to build a SUV that has great reachability and also vision. So scope, our scope must use eco engine instead of normal engine, and must use 95th percentile to do all the analysis, including vision analysis, comfort analysis, and many others. So here is our company organization part. Sharvindiran will be COO, and Daniel will be manager, and Soban will be engineer. DUBOYUAN will be sales and marketing, and me as sales executive. Thank you. That's all for me.
My name is Daniel Sharvindiran, and my matrix number is MH19044. And I'm going to help my group present about our company So this is our company logo. So the definition are the Autopro logo means the capital A, but naturally in a modern design. The wings modern design. The wings on both sides of the logo is for showing that the company wants people to know that we will help people to achieve their dreams. So we go to the next part, is the design methodology. So for the concept model, it must have the three requirements. It is the minimum size for single seat, there is zero emission, and the power consumption. And we go to the next part, is the design consideration. So it must fit the design for the customer and have the affordable price for our buyers to pay it, and then it must have a great aerodynamics, and it must be followed with a green technology to save our earth, and it must have a great power efficiency. So we go to
Hello, good evening. Today I'm gonna present about technical feature of our car, and my name is Sharvindiran GOPALKRISHNAN, and my matching number is MH19054. Okay, let me see the first point. Okay, the dimension of the body. The overall length of the car is 1678. The overall width is 1854, and overall height is 4587, and the wheelbase and tread length is 2660. And then the next, you will see the drivetrain system. The car is coupled with this engine is continuously variable transmission, where you use the CVT. Driver can take advantage of maximum of 190 horsepower at 5600 RPM. Each of the four trim level available equipped with all-wheel drive, and all-wheel drive with energy control system can help preserve some fuel economy that often get lost in AV system. Next, you will see the powertrain system. DOSHC 16 watt piston cycle, 2.0 liter inline for 143 HP, 129 lb-ft. Permanent magnet synchronous AC motor, 181 HP, 232 lb-ft. The combined output 212 HP and 232 lb-ft. 1.4 kilowatt lithium-ion battery pack. So the auxiliary feature is a vehicle stability assist with traction control, LED daytime running light, multi-angle review camera, an advanced front airbag with a rollover sensor, and forward land collision warning. So next we will see the vehicle competitor for our car, 2020 Mitsubishi Outlander and 2000 Hyundai Tucson. Okay, we will see from the engine type. For three of them, the displacement are same. The horsepower for two of them is same, 184, where the Mitsubishi Outlander only 166 HP only. The torques are same for both the Autopro and the Hyundai Tucson, where the Mitsubishi Outlander only 162, and the transmission for both three of them are same. So next we will see about the chassis. Okay, for Autopro we use architecture. For Honda Tucson we use unibody, and also Mitsubishi Outlander unibody. The suspension front and the suspension rear for three of them are same. So the brake rotors for Mitsubishi 60.6 over 60.6, where AutoPro and Hyundai Tucson only, the value is 63 or 63.7 for both of them. So that's all from me. Thank you.
Good day, doctor. My name is Sharvindiran Ramaya, metric number MH19052. Today, I would like to present my part of the project, which is the AutoPro sketching designs, flowchart of SolidWorks, AutoPro's modeling, AutoPro's final design, computational fluid dynamics, CFD of the AutoPros, and downforce and drag force from CFD. Okay, these are the AutoPro's sketching design that I made initially. The above diagram shows the tire sketchings, and below is the steering wheel sketchings. Okay, this is the flowchart of SolidWorks. How I did this model using SolidWorks. I would like to explain it briefly. Okay, part 1, number 1 is installing SolidWorks. Number 2 is modeling the basic desired car shape. Number 3, making different models of parts such as steering wheels and tires. Number 4, detailing the parts and our model, such as adding features, more surface planes, gap for windows, inserting tires, headlamps and signal lamps. Number 5, detailing the steering wheel and tire also to make it look more realistic. Then number 6, we assemble the separate parts to make it a finished car model. Then providing color to the AutoPro model. Then also applying real view graphics, which will also make it look realistic. We go to the part 2, applying CFD analysis to the already done AutoPro model, which we know can be done by SolidWorks. Number 8, applying cut plots, goal plots, surface plots, and trying out different flow trajectories to see the CFD flow. Number 9, getting the downforce and drag force values and graph using the goal plot functions, which I will explain later. Then number 10, saving the flow trajectories, animation, downforce and drag force graphs, and the different plane views of our AutoPro model for the presentation purpose. That is all, the end. Okay, these are the AutoPro's modeling I did separately before assembling it. You can see all the different parts. This is the AutoPro's final design after I assemble it, providing color to it and using a real view graphic to make it look more realistic. Okay, we move on to the computationally fluid dynamics CFD of AutoPro using SolidWorks. The above two diagrams, you can see the cut plot views of our AutoPro model. You can determine the level of pressure by seeing the color of the green screen if you see. Then below is the surface plot view of AutoPro. You can see the pressure exerted on the surface of our AutoPro model. Okay, now I would like to show a short video of the flow trajectory animation of our AutoPro model. I use the lines of noise CFD flow. Okay, that is all. Moving on to the downforce and drag force of our AutoPro model. Just as I told you just now, we can use the goal plot function in the SolidWorks to get this table and all the values. So from the table, we can get the value of downforce X is 2.289 Newton. Meanwhile, the value of drag force Y is 0.23 Newton. This is the downforce X graph of our AutoPro model. You can see it gradually decreases until the value 2.289 Newton. And finally, the drag force. Okay, you can see the drag force Y graph of our AutoPro model, which is increasing until the value 0.239 Newton. Okay, that is all for my part of SolidWorks designing and CFD analyzing. Thank you very much.
Okay, hello everyone. My name is DUBOYUAN. My metric number is MH19047. So I will talk about cost and break-even analysis. So we use how many units do we need to sell monthly to break even? This question to discuss cost and break-even. So analyze this problem is depends on fixed coverage and the service operation. So the total fixed overhead is net of the total direct expenses less the total variable expenses. So for example, if we fixed coverage is 60%, then the absorbed expense or bond as is commonly called is 40% plus the total of variable expenses. So the way subtract the total of variable expenses and the unabsorbable expenses from our total direct expenses, which equals to the unabsorbable expenses or the money amount of gross. So we must generate so new and used vehicle sales and the net financing and the interest. This is unacceptable expenses is then divided by our total gross pre-vehicle to determine the number of units we must sell to break even. So we also reduce the number required to break even by lowering our expenses, and we also can increase our fixed costs. So we increase our total gross per new and or use retail, or we can use any combination of the three methods. So this is fixed cost and the variable cost. Fixed cost with variable cost is the difference in current business costs at either static or fluctuating when there is a change in the activity and the sales value. Fixed cost includes expenses that remain constant for a period of time for the level of outputs like rent, salaries, and loan payments, while variable costs are expenses that change directly and proportionally to the change in business activity level or volume, like direct labors, taxes, and operational expenses. So fixed expenses have auto insurance, property taxes, and variable costs have oil, free and tears. And this is break-even units. So break-even units equal to fixed cost divided by revenue per unit minus variable cost per unit. So when we determine a break-even point based on sales money, divided the fixed cost by the contribution margin. The contribution margin is determined by subtracting the variable cost from the price and of a product. Okay, thank you.
So we go to the next part is the safety and regulation. Okay. So, for the seat belts and head restraint. The head restraint is only for the driver, front seat, and for passenger and the rear seat. So the advanced belt feature are the standard features, and it has a adjustable upper belt anchorage for the drivers and the front passengers. The seat belt reminder system is only for the driver and the front passenger. So for the airbags, it have a frontal airbags for the driver and front passenger only, curtain, driver, front passenger, and rear seats. So the torso, pelvis for airbags is only for the driver and the front passenger. And yes, it does meet size airbags out of position requirements. So the conclusions are: it must have a great design with affordable price to customer due to COVID-19 and to help them due to loss of incomes. The car also need to be using green technology due to air pollution that rises nowadays to create a better surrounding. The safety of the user is also a requirement to be filled in our cars, so buyers have no hesitation to choose our car. That's all for me. I'm going to pass to my next teammate.